Today we're doing the law of signs, LOS, law of signs of the ambiguous case. That is when you're given two sides and an angle, but not just any angle. If we're given two sides, then it has to be an angle opposite of those two sides. So if we're given side B, then it has to be beta. If we're given side A, then it would have to be alpha. But we are not given gamma because we're not giving C. If we were giving gamma, then that would be a different case, and that would be the law of cosines in that case. So if we're looking at this, the ambiguous case, the reason why it's called the ambiguous case is because there is going to be a possibility of having two triangles, one triangle, or no triangles. A few of them are going to be a little bit more work than the other ones. So some of them are going to be really easy and some of them are going to be a lot of work. But if you look at it, because it has three cases, it is going to be a pain in the butt. But look at how it's spelled backwards. Anyway, so let's try to fill out this chart and understand it. We are going to be able to have an acute triangle if the angle that's given to us is an acute on there, or it's going to be an obtuse triangle and it's going to look like this. Let's work on the acute triangle for right now. So I worked with GeoGebra and I made this up so that hopefully it is better to understand the concept, because it's not that bad as long as you could see the visual of what really is happening. So filling in that chart over there is that we're going to be given a side opposite. So this is the side opposite and this is the angle that's given to us. And then it could be an adjacent side. It could be either this side or this side that's adjacent to the angle. Let's assume that the adjacent side is this one. So in order for us to know it's the ambiguous case, it's whether it's going to form one triangle, two triangles, or no triangles at all. So how are we going to figure this out? Well, if we're given that the opposite side is 10 and the adjacent side is 15, and we're given that the angle that's opposite of that opposite of that side is 65, then we're going to be able to figure this out. In a triangle, we have this vertex and that vertex, and this vertex is going to connect to another vertex down here on the blue line. The shortest distance from C to the opposite line is going to be a direct straight route where it's going to form a right angle with the blue line down here. And so in order for us to do that, that's actually called an altitude or a height. So if I put that in there, this is going to be the shortest distance on there. So the height, the altitude is making a right angle right here. And how are we going to find that with the information that's given? Well, we could do the SOHCAHTOA information that we did before, where we do sine of alpha is going to be opposite over hypotenuse. And if we simplify and we solve for h, it actually gives us that it's going to be the adjacent side times the sine of this angle. So if I do this formula, that's how I calculate it. And we get that the height is going to be 13.5 units, whatever measurement, centimeters, meters, miles, whatever it is. So this here is going to be that length. And if this is the shortest distance, that means that the opposite side has to be the smallest distance of h. Well, the opposite side is 10. And if you notice, the opposite side of 10 is never going to reach the blue line. If it's never going to reach the blue line, it is never going to form a triangle. So in this case here, if we could figure out what h is, we could compare that and know that we are done. There is no triangle, no solution done with that. What happens if the opposite side is not 10, but 13.59? So if it is 13.59, then we are good to go, because what's going to happen is that it's going to be equivalent to the height. If it's equivalent to the height, this forms a right triangle. It has one solution, and we could solve the triangle, meaning we could find all the angles and all the sides by using SOHCAHTOA, because that's the only time you could use SOHCAHTOA is when it is a right triangle. What happens if it is bigger than 15? So what happens if it is bigger than 15? So I'm just going to jump from 13.5 and then bigger than 15. Well, what happens if it is equal to 15? Well, if it's equal to 15, now this is what's happening. If it's equal to 15, then what's going to happen is that if I go on this side, it is going to be exactly like that. And it is not going to form a right triangle because, I mean, it's not going to form a triangle, let alone a right triangle, because it's going to go all the way over there. But that does not mean that I do not have to go on that side. I could also go on the opposite side and notice how this now green line I am forming a triangle. And so this forms a triangle right there, and that's the triangle that we're looking at. So in this case here, when the adjacent side and the opposite side are equivalent, we form an isosceles triangle. Okay, so now what if I continue with this and say that this here is bigger than 15? So if it's bigger than 15, let's say 17, then again, I can't go to this side over here. I can't form a triangle on this side. The angle is right here, so it's not going to form a right angle right there or any angle there, and it's not going to form a triangle. But I could form a triangle over here, and I could adjust it this way, and now I am going to have a triangle that looks like that. Very good. Okay, so now why am I going to the other sides on there to see what's happening? It's because that is possible. What happens if I have a length of the opposite side that is bigger than this height, but less than the adjacent side? So let's say that it's between, let's say, let's give it 14. What if I say 14? So what if the opposite side is 14? What happens? Well, if it's 14, that means that the height is 13.59, and that's bigger, that's smaller than 14, and then 15 is smaller. So that means that this length is going to fall right in between there. And if we look at that, it's going to touch the opposite side in here, and it's going to touch the opposite side over here. So if we look, what's happening? It's actually forming two triangles. So if, oops, let me trying to grab the other point. Okay, so it's actually forming two triangles. So I am going to get rid of the height because now we know the height is going to be there. And so I am going to get rid of the height there. And so now this is actually forming a triangle over here because it's touching it over there. So I'm just going to go over here and it's going to form this triangle right there. And that is called an obtuse triangle. This angle right here is going to be greater than 90 degrees. So that's going to form an obtuse triangle, but it's also going to reach the other side over here. And if we notice, that is an acute triangle. And so therefore it's going to form two triangles. So it's going to form to the left and then again to the right, a triangle. And those are the two triangles that we're talking about. So if we look at this, the main thing you need to take in here is that if the opposite side is in between the length of the height and the length of the adjacent side, it's going to form two triangles on there. Okay, so let's go back and fill out that table there. So if the adjacent side is 15 and the opposite side is 10, that means that the opposite side, and we know that the height was, so if we look at this, the height was, let's erase that. We know that the height was 13.59. So comparing it, the adjacent side is 15. And this one here is smaller than the height, so therefore we have no triangle. We have 15 as the adjacent side. This is equivalent to that, so we have a one right triangle. If it's greater, if it's 14, that means that it's between 15 and 13.9. We have two triangles. If the adjacent side and the opposite side, that's an isosceles triangle, and we have one triangle. And if it's 15 and 17, that means it's greater than the adjacent side. We have one triangle as well. And so there you go. So let's start with this box over here. So filling that out, that means that we have an obtuse angle instead of an acute angle. So what we were given was an acute before, and we're going to get obtuse one now. So going back to what we were doing over here, let's say that the angle now is 135 degrees. So it's an obtuse angle. And so now we have to look at the different cases here. So the adjacent side is still 15. What could the opposite side actually be? So if it's 10, we notice that we don't have the height anymore because the height is going to be outside because it forms a right angle if it extends over here. But if I have it to be 10, it's not going to form a right, a triangle at all, not even a right triangle, because it's an obtuse angle anyway. So if I look at that, it is not going to form a triangle. Now, what if happens if I change this? What if I go to 13.59, which was the length of the height from before? So And so our answer is still here. Notice how it's still not going to reach because if you look at it, it's not even going to reach from the opposite side. We From the adjacent side is 15, the opposite side is 13.49. It's not even going to fit there. What happens if we have it to be anywhere between 14? It's still not going to work. So if I look at that and I do 14, this here is not going to reach as well, that's not going to reach, and then, of course, if it's 15, it's going to reach, but it's not gonna form a triangle because it's just the same thing, it's just gonna lie right on top of that angle right there, so it's not going to form a triangle at all. And so now if we choose 17, then if I look at that oops, keep doing that. If I do 17, it's going to form that. Notice how it's not going to go all the way over there, but it's bigger than 15, so it's going to reach at one place or another. So that just means that we're going to have it look like this. And if I look at the triangle, that's the triangle that it's going to make. It's still just one triangle, but what we learned here is that the opposite side, if it's an obtuse angle, the opposite side has to be bigger than the adjacent side. Otherwise, it's not going to form a triangle at all, and it's going to be just one triangle. So the only thing that we really have to worry about is when it's an acute triangle, that's when you have all the different cases from before. So if we fill out this table over here, we know that these are all going to be no triangle, and then just when it's bigger there, so this is going to be no triangle all the way down, and then the only one is going to be one triangle when the opposite side is bigger than the adjacent side, and that's how you would do um, the acute triangle and the obtuse triangle with side, side, side. Very good.